Hello everyone and welcome. So we're going to start off with this problem here. We'd like to construct an equilateral triangle with the side length of AB below. Okay. Now, alright, let's see. Equilateral triangle, all the sides are the same here. So we need to find a position of a point C so that it's the same distance away from A and B, and that distance should be AB here. So we know that point B, right? Point C, the third vertex of our triangle, is going to be, this distance AB away, which tells us, okay, I better probably draw myself an arc. So I'm going to construct myself an arc like this here. So I can set my compass to the length of AB here. So hopefully that works out. And I can go ahead and sketch this out here. You can go ahead and construct something like this here, and you'll see that I can draw this arc like so. So we know point C is somewhere on this arc, right? Now, we're not exactly sure, but we know point C is also AB units, whatever this AB is, away from A as well. So which means that I can do the same thing over here. I can create a circle centered at B with a radius of A, and draw this and construct this here, like so. And we get something that kind of looks like this here. So now I've got two arcs, one centered at A, radius AB, one centered at B, radius AB. Well, where's point C? Well, point C here, as you can see, remember we mentioned this before, that we have an intersection of specific points here. So we have our intersection like this. So as a result, we know that point C is going to be up here, right? So let's call this C1. So notice that C1 is up here, and I can go ahead and finish my construction like so here. And we can see that ABC1 is this equilateral triangle that we've requested, right? That seems to work out. Now, of course, you didn't have to pick C1. You could pick C2 on the bottom here. You could have picked this point down here as well. So here's C2, right? And we could have done the same thing here. So we draw this in. We draw this in as well. Ah, very nice. As you can see here, ladies and gentlemen, we have ourselves something that looks like this. All right. So now, as you can see here, we have two positions for C. It could be C1 or C2 here. So now I want to look at this quadrilateral here, AC1, BC2. Now, what do we know about this object? Okay, well, let's see here. Notice that whatever this was, AC1, BC1 are the same because it's an equilateral triangle by construction. But notice that it's also the same, they share AB. But notice the same is true down here. AC2 and BC2 are the same as well. So notice that every single one of these segments here all match segment AB here. So that means all four sides congruent, right? Now wait a minute. If all the sides are congruent, if you recall, we did this, previously, this means that this has to be a rhombus. And that's great. So notice how in this situation here, we end up with a rhombus that looks like this. So if AC1, BC2, that actually has to be a rhombus here. Oh, that's wonderful. So notice, ladies and gentlemen, one of the things you remember about rhombus, so let's see, what do we remember about rhombuses? So rhombuses, one of the useful things about the rhombuses here is that the diagonals are perpendicular, right? So which means that if I were to connect C1 to C2, like so, C1 to C2, if we look at this point here, let's call this point here D. What's true about this point D? Well, we know that it creates right angles here, so it's perpendicular like so. But also another really important thing here, ladies and gentlemen, is the fact that, hey, the diagonals of a rhombus bisect each other. So that means AD and DB have to match as well. So in doing this, notice that we've actually gone ahead and constructed ourselves, this thing here. We constructed a way to find the middle of a line segment. This point D is guaranteed to be the midpoint of AB here. So as long as we can construct a rhombus, we're guaranteed of this here, right? So we have the fact here that therefore from this we have AB is perpendicular to C1, C2, and D is the midpoint of AB, right? So that's actually really helpful here because that tells us, okay, now we have a method to split a line segment in half. So all we got to do is just do the, all we have to do is sort of, again, take this picture here and reconstruct it. Now, we can sort of strip this down here to the barest essentials. So what we're going to do is we're going to create a rhombus here, okay? So our rhombus can be whatever radius you want. So in this case, I'm going to choose here A to B. Now, one of the things we'll discuss later on is that all we care about is that this is a rhombus here. So we can go ahead and do this here. Right? Okay. So you can see here, this is going to be my step 1. Okay? And now we can do the same thing from B. We do this here. Same thing here. And you'll notice that this is going to be step 2. And we want to make sure that this is the same radius as step 1. Okay? And then finally, now that we have this here, we can now go ahead and construct this. We can kind of do this here, right? We can go ahead and I have my 2 points here, one here and one here. Take my straight edge and construct that. This is going to be step 3 here, and as you can see, the midpoint is generated here. Okay? And therefore, our construction actually looks very nice here. This is our construction for the bisection of line segments. Okay?